right, so they find area. I don't like this pen. Let's try this one. And you know when you have a definite integral because you have this interval. There's a starting point A and ending point B, and there's some type of curve or function f of x dx. I don't like this pen. What's happening to all my pens? Look this one. And one thing that I should tell you, because it's going to come up, is that A is less than B. Okay, so the bottom number should always be smaller than the top. Okay, because you're going from left to right. And the reason we go from left to right is we read from left to right. Okay, so right here, it's telling you start at 0, end in 12, and figure out the area under f of x. And this is f of x. I'll make it a little bit darker. Right here, it's hard to see. And so these have geometric shapes, correct?
Indeed. I just
Okay.
need, can you tell me the formula for finding the area of a semicircle? Is it pi radius squared?
Well, how much is that a full circle?
Pi radius squared over 2. Is that the...
Correct, that's correct.
Okay, so got it.
So what is the radius here?
That'll be pi 4 over 2, which would be pi 2 pi.
2 pi. Okay, perfect. So I'm going to write 2 pi there. And then what am I going to do here? I can section this off, correct? Didn't we do something like this before? Am I right?
Indeed.
So this is 2 by 2. So this has an area of what? 2 times 2 divided by 2. Correct? Because it's a triangle, and that gives me what? 2. And this gives me, what does it give me here? 2 also? What about here?
1.
1. So right now I've got 2 pi plus 5. Does that look correct? And 12 is here, so I'm going to figure out the area here. And it is also a triangle. That's 1, 2, 3, 4 across, right, Audrey? 2 high. So it's 4 times 2 divided by 2 is what? 4. But that's 4 below, correct?
There's 2 pi plus 1.
So I'm going to subtract 4, and I'm going to get 2 pi plus 1. Would everybody agree with that? Everybody okay with that? All right, so now if you look, you got something kind of crazy. It says, all right, start at 12 and go in the direction of 0. So I'm going to go in the opposite direction. What do you suppose my answer is going to be for area? If I'm going in the opposite direction. Yes, sir.
Negative 2 pi minus 1.
Negative 2 pi minus 1. Perfect. In fact, you just multiply by a negative 1,
Yeah.
correct? Okay, does that make sense to everybody? All right, so we're going to learn some properties, okay? And then I'm going to show you what kind of questions you get about those properties on the AP exam, okay? And one of the properties that we have that we use quite a bit is we're starting at A and ending at A. That means we have moved nowhere, correct? So much, how much area have we gained if we have no interval? 0. So anytime you integrate from the same number to the next, the same number to itself, it's automatically going to be 0. Okay, whether it's integrating from 2 to 2, 3 to 3, pi to pi, doesn't matter, it's going to be 0. There is no area under that section. Is that making sense? All right, super. So now if you take a look, here we have it reversed. Well, it's kind of like what we had up here, correct? So what we do is we rewrite this. Remember we said we just gotta multiply that by a -1. So I'm just gonna write a negative outside and then replace the A and the B. So in this case, since going from A to B was 2 pi plus 1, and I would simply multiply that area by a -1, I get a -2 pi minus 1, and that would be the one that we just did above. Okay, so that's the property. When you see them interchanged, when the smallest is on top, all you do is reverse them and multiply by a negative. This one is K is some constant. So all that means is you can bring the constant out front, figure out the area from A to B, and multiply it by that constant. And lastly, what we have here is what we call adjacent intervals. Notice that C is between A and B. So I have an area from A to C that I'm going to figure out, and then I have an area from C to B. Well, that gives me the same as going from the area from A to B of f of x dx. And a lot of times we use it in this manner. I'm going from A to B, but there's a value that's in between them. So I figure out that value, and then I figure out the next value, and then I can add them together. All right. This one addition means I can actually add two integrals. So I'm integrating from A to B of f of x dx. So I figure out that area, and then I can integrate from A to B of g of x dx, and I figure out that area, and I can add them together. So I can separate them as two individual integrals. Likewise, I have subtraction. I can write them as the difference between two integrals. So they'll still have the same constraints, A and B, f of x dx, minus the integral A to B of g of x dx. Again, it means you can go both ways. So if I have something like this, I can combine them that way. If I have them, a lot of times I'll take them, if they're different types of functions, I'll separate them and look at them individually. You'll see me do that quite a bit. All right, so here's this particular one. If you remember, it says, okay, I want to integrate from 7 to 6. So I'm going to rewrite that. I'm going to integrate from 6 to 7 of f of x dx. I'm going to figure out what this area is first, and then I'm going to multiply it by a negative. Well, here's from 6 to 7. So we're talking about this particular area right here. And we had that been as an area of what?
5. Just that section?
Just this, from 6 to 7, right here, because it says 6 to 7.
2.
2. So since I'm multiplying by a negative, it's going to be a -2. So this one can be rewritten. I'm going to write the 8 and the 12. I'm going to have a negative. There's going to be an f of x here dx. And since 3 is a constant, I'm going to bring the 3 out. Owen, we doing okay with that, how I did this? Why I did it that way?
Yeah.
So if I look from from 8 to 12, that's this area right here, correct?
Mm-hmm.
And I believe from before we figured that out to be 4. Am I right?
Yeah.
So I'm going to take that -3, I'm going to multiply by 4, and I'm going to get a -12 as my answer.
No, you get a 12 due to the fact that it's underneath.
I get a positive 12 due to that it's underneath. Right, because we really treated it like a -4. Thank you. All right, so let's take a look at this. they give you some integrals. They say, notice there's no function, there's no picture. They're saying the area from underneath between f of x and the x-axis from -2 to 1 is 4. The area here from 1 to 5 is a -3. From -2 to 1 of g of x is 8. And they're going to ask you to figure out the following. So the first thing I see here is I see that A is bigger than B. So I'm going to rewrite it this way. And so I need to know what this is. And Ariana, what is this right here? What's the, if I ignore that negative from 1 to 5, do they give me that anywhere? It's a -3. So I got to multiply that -3 by a negative, correct? A -1. And I'm going to get, what is the answer? 3. Perfect. Now, if you notice here, I have, Jonah, no -2 to 5, do I?
No.
But if you notice, I go from -2 to 1, and I go from 1 to 5, can't I? So this is going to be the same as the integral of -2 to 1 of f of x dx plus the integral of 1 to 5 f of x dx. Because they have, this b is the a over here. And when I attach them, I'm going from -2 to 5. So what do you want me to put here?
4.
And what do you want me to put here?
-3.
And I get
1.
perfect. Tyler, I can rewrite this as -2 to 1 of f of x dx plus, I can bring the 2 outside, because that's a constant, from -2 to 1 of g of x dx. What is this value right here?
4.
And over here I'm going to have 2 times, what's this value right here?
8.
And so 2, right, you got to do the 2 times 8 first. Okay, and what do we get?
1.
Very good. D, 0 to 1. Do I have anything from 0 to 1? Do I have anything with a 0? Cannot be determined. Because I have,
So if one of our intervals is not, so if one of our endpoint intervals of the endpoint is not known on any of them, it cannot be determined.
yes. I need some attachment to 0. Does that kind of make sense?
I think so. Okay.
So, Audrey, how should I rewrite this? What should be on the bottom here? I think you said a -2. What should be on top here?
1.
Then I got f of x here, dx, correct?
Yeah.
What's out front?
3.
Yeah, but because it switched it, it's going to be a -3, isn't it? Okay? And so that gives me a -3 times what?
4.
And I get what here? Rhea, are you happy that I gave you F? Why? Why do I see a great big smile on your face?
Because it's 0.
There's nothing to do because it's 0 because it goes from 5 to 5. I saved that one for you. Okay? Backside. All right, piecewise. Ben, it says it's 3 for x less than 2. So here's 1, here's 2. Would you agree?
Yep.
So what should I do here? At 2, I should go up to what?
3.
1, 2, 3. And what should I put there?
Line.
Okay, but it says, 4x less than 2.
So line going to the left.
And okay, what does the end of it look like?
Arrow.
It's an open, right?
Oh, yeah, yeah.
Because it can't include 3,
Yeah.
right? And then you're saying it's going to the left like that. Okay? Right here, can I put 2 into here?
Yeah.
And when I put 2 into there, I get what?
2.
2. And I can have a closed one,
Mm-hmm.
and it has a slope of what?
1. Or,
Could I write this as plus a negative x?
yeah.
So a negative x means I'm taking x and multiplying it by what?
-1.
So what's my slope?
-1.
Okay, that means down 1 and the right one, would you agree?
Yeah.
And I can keep that going right till the end of the graph, right? Now it says it wants to know the area from 1 to 5. Here's 1, correct?
Yeah.
So what I'm gonna do is I'm gonna come over here, and that's going to be from 1 to 2, that rectangle. How much is that?
3.
And then I've got this little triangle here, correct? How much is that, do you think?
2.
How'd you get 2? Oh yeah, because it's going through 1, 2, 2 this way, 2 this way, yeah, 2. And then how much is this little doodad right here?
1/2. -1/2.
Is it 4.5?
And so my area is what?
4.5?
Equals 4.5. Would you agree with that? All right. Kayla, what's an absolute value look like? It's a particular alphabetic letter.
V.
V, okay? And if I put 2 in here, I'd get what?
Absolute value at 0.
An absolute value of 0, which is 0, correct? And if I go 1 over, so this is 2, correct? If I go 1 over, I'm at 3, correct? If I put 3 in there, what am I at?
1.
1. And if I'm over at 1, what do I get?
-1.
But it's absolute value, right? You said it looks like a
Oh,
V.
so it'd be 1.
It'd be 1. So I'm integrating from 0 to 5. 3, 4, 5. Well, I have triangles, don't I? Would you agree with that? How much area is this?
2.
And how much area is this?
4.5.
4.5. Boy, you did that 5. So what's my answer here?
6.5.
6.5. Very good. Everybody okay on that?
Mm-hmm.
Woo! What's the difference between this? Well, this is saying find your answer and make it positive, correct? So we need to figure out what this is. First. So from -2, Grace, to 1, to 0, excuse me. Oh, what do you notice about these? Except one's what?
One's negative, one's positive.
And they're the same, so like 3, -3, correct? 4, -4, correct? This is gonna be something pi, and this is gonna be the exact same thing but opposite. So when I put these together, what do I get?
0.
Excellent, Grace. Okay, 0. So that means I got 0 here, and then I'm coming here, right, because it says go to 4. How much is this thing, Grace? 2. So my answer here is going to be 2. Would everybody agree with that? Because the absolute value of 2 is 2. I suppose I should do this. A good teacher would do that. Now, this is saying all your y values have to be positive, correct? Because f of x are y values. So what I'm going to do is these y values are the only y values that are negative, right, Colin? So they're gonna turn up and they're gonna, that's not a very good diagram because I went too high. But it's gonna be like this. That's better. Okay, Colin? So I actually need to know the area of this. So what's the area of this, Colin? The radius is 1. Pi r squared divided by 2. Can I write it as pi over 2?
Yeah.
You're right with 1/2 pi. So this one's 1/2 pi also,
Which equals pi.
which is equal to pi. Is he correct?
Yes.
So what would I write down as my answer here?
Pi plus 2.
Pi plus 2, perfect. They love giving you questions that have, where the answers have pi, okay? And even if I can use a calculator, I don't go to my calculator because really, I can write pi a lot quicker than turning my calculator on. All right. So, what is this? Well, it wants to go from 2 to 3, so 1, 2, here's 2. And so it's the and when I put 2 in there, I'm going to have 2 minus 1, which is 1, and the square root of 1 is 1. And then I'm going to go to 3, and 3 minus 1 is 2, and the square root of 2 is 1.707. How do I know that? Because I used to have that memorized. So anyway, here's the graph. So I'm going to show, the reason I got this is one of the things you're required to be able to know is how to integrate with your calculator. So you're going to need to get your calculators out. And where are my calculators? Probably got it buried. Well, I got my Casio. Where's my other Casio? Oh, right there. So I'm lent somebody my TI. So, Jonah, can I borrow your TI?
Yep.
Because yours is an old one like mine, right?
Yeah.
I lent it to somebody. So, one of the ways you can do it is you can go to math.
So this is for TI, not Casio.
Yeah, I'm gonna show you in a Casio.
Okay, so I'm just.
And I'm gonna come down here, and this was your derivative, this is your integral. INT, function integral it means. So I'm gonna choose that. I'm gonna put in my function, which is second square root x minus 1 parentheses. Then I gotta tell it you're integrating with respect to x, just like you take derivative with respect to x. Follow it from with a comma, and then you're going to type in the a number first and the b number second. So it's going to be 2, 3, parentheses. Okay? If I press enter, you should get that as an answer. Did everybody get that? Okay? That's the first way to do it. The second way to do it is you can go to graph. Oh, you already graphed it, huh?
Yeah.
You already figured out how to do this. Okay, so there's the graph. And you can go second, calc, and right down here there's an integral. Press enter. What's the lower limit? What is it, 2?
2.
And the upper limit is 3. You press it, and it shades it in. It puts those little tiny rectangles on it, and it gives you the same answer. Either way is fine. Everybody okay with that? All right. Casio.
Should we go to graph?
You want to do the graph first?
Sure, I'm going with that, I think.
Okay. Menu, graph, delete what I got here. Second square root, parentheses.
We can't
X.
see the whole calculator.
What?
We can't see the screen of all things.
Is
Just
that
go-
better?
Yeah, no, just gotta wait for it to clear.
I'm trying to find, I gotta delete here because I made a mistake. Minus 1 parenthesis.
Yep.
And I'm gonna go to my window and I'm just doing a standard window. Okay, STD means standard,
Yeah.
okay? And so I'm gonna hit draw, and there it is right there. Okay? Now, up here you see where it says G-solve?
Yeah.
You go shift, G-solve, and you see the right arrow here? F6. Should have an arrow above it. Did it?
There's a 0.6 repeated.
Oh, you're ahead of me. So do you see where it says integrate F3? And I'm going to put in 2 for the lower bound, 3 for the upper bound. It should shade it in, and I get 1.219. 1.219.
Yeah, I accidentally did 1 to 2.
Yeah, okay, you see
Yeah.
this though, okay? And then if you were to do it here, you should have you go to option. So if you look at your first line, you got shift, you got OPTN, that's option. And then you should have calc as your option.
Yep.
And then you should have a little integral symbol, which is an F4.
Mm-hmm.
And then I can go shift, square root, x minus 1, I'm gonna put in parentheses, I never remember you. And then you just gotta put a comma, and you just put the lower, and then you just put in the upper. You don't have to put an X like TI people do. And so when you do that, you should get the same answer.
Yep.
Okay, so it's under option.
Yeah.
Okay.
I think I get it now.
Everybody okay on that? All right, so I want you to do this one. I'm gonna draw it. So if you take a look, my y-intercept is a -1. And does everybody see that x over 3 minus 1 is equal to 1/3 x minus 1? So that tells me the slope is 1/3. So I go up 1 and over 1, 2, 3. And it wants me to go to 4. I think 4 was somewhere like here. And so that's the area you're computing. You're going to do it on your calculator. Now, before you do use it on your calculator, should the answer be positive or negative?
Negative.
Why?
Because primarily most of it is in the negative side.
Right, most of it is below the x-axis, correct? Oh, and I didn't go far enough, I wanted to go to a -2. Yeah, make sure you go to a -2.
-4 is our answer.
Everybody get -4? Got -4, you did well on your calculator. Now, you are going to have calculator, and it'll say a calculator should be used, and right away, you'll wanna put that into Y1. Does everybody understand that? This would be 3 points. You would get a point for this part of your graph. You'd get a point for this part of your graph, and you get a point for the answer. So this is what you would write, and then you write down equals, and let's say you wrote it all correct, but you made a mistake on your calculator, and you wrote 3, because you like 3. You would still get 2 out of 3 points because you wrote the integral correctly. They don't grade you on how well you know your calculator. Does that make sense?
So what they're asking me is I need to write that equation that was the printed equation.
Right. And we'll get to problems like that,
Okay, because I'm.
and they're
kind
gonna
of
say,
confused
okay,
on that.
what is this? Well, all you have to show me is the integral and the answer, and they know you did it on your calculator because it was calculator active, or it said, for this problem, you wanna use a calculator. Does that make sense to everybody? Okay, we're moving on to the next section then, which is 6-7, am I correct?
Yep.
And it looks like this, definite integrals.
Yep.
Okay, you're gonna learn some shortcuts,
Ooh.
okay? We're gonna bring in something